Hello. Okay, we're going to do questions 10 through 13 on the U-Texas. So, one thing I want you to notice, there are these multipliers, okay? I'm going to tell you right now that when I give you a problem on a test or quiz, I'm not going to have these multipliers. I think they're good for practice and for homework, but on a test, I wouldn't give these extra multipliers here. So if you saw this scale, I want you to notice that the answer here is not, or this is not really 6. It would be 6 times 9. Or really for this one here, okay, this is not going to be 3. It's going to be 27, 3 times 9. If you want to, because you only really need these endpoints, you can multiply it out and just change this to a 27 here. All right, same down here. Do not forget your multipliers. This is not really 4. It's 4 times 5 or 20. So just be careful with that as you go along. You might remember to do it for one step, but forget to do it the other step for all the questions. So make sure you do them for all. Okay, so first off, what is the initial velocity? Well, we see this, we're going to read. We have velocity versus time. At time equals 0 seconds, the velocity is 0. Okay, so that's going to be for everybody. But anyways, this velocity is going to be 0 because you just read it. Same with the final velocity. We got to read this part. All right, well, it ends at this point in time. Don't forget your multiplier. I have 4 times 5. So at 20 seconds, my velocity was 3 times 9. So my velocity is going to be 27. So far, so good, right? All right, now, going down here. Final position. This is a little bit trickier, but remember this. I've mentioned this already, that the area underneath a velocity versus time graph is displacement, okay? This is your displacement right here. Now, you have to read earlier in the question, okay? On question number 10, and I don't have it pictured here, but it somehow came over there. On question number 10, in the wording, before this point, you're going to see an initial position given. It'll give some kind of initial position as starting point. Okay, my initial position is 13. Okay, so down below, again, if my area underneath here is going to be my displacement, I'm going to have to add to it my initial position to get my final position, which is what it's looking for. It's not just asking for displacement, it's asking for final position. Okay, how do I get area underneath this? Well, it's area of a triangle. 1/2 base times height, right? So all I'm going to do is my 1/2 base times height. All right, so I have 1/2. My base was 20. Don't forget your multiplier. All right, my height is 27. Again, in your calculator, it might be easiest to do 0.5 for the 1/2. Multiply that out, and you will not get your answer because then you just need to add to it your initial position. And my initial position was up here, and it's 13. All right, and that will get you your final position down here. All right, last, acceleration. Remember the mantra. If Mr. Spudik gives you a graph, he is going to ask for slope. So velocity versus time, the slope represents acceleration. All right, so we're just going to get the slope of this. As always, it's rise over run. Okay, so when I do my slope, you could do y2 minus y1, which I'll do now. So y2 minus y1 over x2 minus x1. All right, so my y2, again, don't forget your multiplier, is 27. Your y1 was 0. My x2 was, don't forget your multiplier, 4 times 5, 20. My x1 is 0. So I have 27 divided by 20. Divide that out, and you'll get your answer.